7.6 two-step algebraic equations. I can solve two-step algebraic equations.
Excellent. We can solve two-step algebraic equations, right? And in some cases, they're actually three-step algebraic equations when we combine like terms and distribute. All right, like terms. Terms that have the exact same parts. And when we're talking about parts, we're talking about do these two terms have the exact same variables and exponents?
Yes.
So can you combine them?
Yes.
Do these two terms have the exact same variables and exponents?
Yes.
So can we combine them?
Yes.
Do these terms have the exact same?
No.
Does this term and this term have the exact same? You get the idea? Excellent. When combining like terms, I'm going to skip down to number 4. We did this thing with circles and squares and triangles. What do we call that? Excuse me?
Coding.
I would like everybody to participate in this. Everybody. It's called coding. And we coded 7xy and 2xy, plus 2xy by the way, as red circles. Why did we circle those in red? They have the same what? They're like terms, they have the same parts, right? They have the same exponents, and they have the same variables, right? Negative 12, we call this a what? No, we call it a, not the shape, we call negative 12 a constant. And then negative 4x squared y, there's nothing like it, so we put it in a triangle. And then we just combined all of our codes together. The red circles got combined to be, hello? Not my video. The red circles combined to be 9xy. What did the black square combine to be? It's the exact thing. And what did the green triangle combine to be? No, it combined to be negative. Don't forget the negatives, right? Number 5 was just a gigantic long one. And then number 6, we concluded but said to combine like terms, you should code and then combine. All right, number 7. There's a lot of stuff in this lesson, you guys. On number 7, we had 2x minus 4 equals 12 in blue, right? Our goal is to do what?
Get the variable alone.
Get the variable alone. What is being done to the variable, everybody? It's being multiplied by 2, and it's being subtracted by 4. So we have to decide which one we want to take care of first, right? To get the variable alone. Why did we decide, somebody raise your hand and tell me, why did we decide to add 4 first? Melissa?
Because it's the first thing we learn.
It's the first thing we learn. It's like the easier of the 2 steps, right? Addition and subtraction we learned before multiplication and division, right? So let's get rid of the subtraction by adding. And then we got left with this, 2x equals 16, yes, no? And how do we get the x by itself? Divide by 2, right? Number 8 is very similar. Number 9, we had 60x minus 40x plus 10 equals negative 10. What did we do before we even started solving for x? What did we do before we even started solving for x, Donia?
You combine the like terms.
If you have combined, or if you have like terms to get, or if you have like terms, should you combine before you start to solve?
Yes.
For sure. And then our new problem became much easier. Negative 20x plus 10 equals negative 10, and then we did all of our steps. And then number 10, the last one, before we started solving that one, what did we do, everybody? We distributed. What did we distribute? What number? 4 to the, and to the, so what's 4 times x? What's 4 times 6?
24.
And then it still is equal to 48, right? What's our goal then in solving this problem? What's being done to the variable?
Multiplication.
What's easiest to undo?
Addition.
How do you undo addition?
Subtraction.
So once we took care of all that, we had 4x equals 24, right? What's the goal?
Get the variable alone.
What's being done to the variable?
Multiplication.
How do you undo multiplication?
Division.
Any question?